Welcome to Canaveral Research Center's Kepler Astrology Research Team. It's Tuesday night, and Mitch is here from Tallahassee. He's got a great lesson lined up for you, so I'm going to turn it over to him.
Well, thank you, Courtney. I'm going to go ahead and start my slideshow. You should now be able to see the Kepler Astrological Research Team slide.
Yeah, it looks good.
Tonight what we're going to do was really focus in on the chi-square test and the chi-square statistic so that people can make sense of the journal articles that they might read in astrological research. There's a lot of table-based research, and those tables tend to use the chi-square statistic. I'm going to go over the chi-square statistic and how we calculate it so that we'll take the mystique out of it. We start off with first what a statistical inference is. In the statistical inference, what we're trying to do is we're trying to make an inference about a population of data. A population is all of the data on a given topic. It's all the possible data that you could possibly gather. Tonight, for example, it would be the whole electorate, would be the population. Exit polls don't survey everybody who's going into the election booth. It's impractical to be able to survey everybody who's going to vote tonight. Instead, they take a scientifically devised sample of people and they try to make an inference from that sample to the larger population of all voters. So they take a sample of voters and try to make inferences about from how they voted as to how the larger electorate voted. A statistical inference is a procedure that allows a researcher to decide between two hypotheses about a population. What we're trying to do is the values that a population has, we call a parameter. Those are unknown. We don't know what they are. We don't have them. We're trying to make an inference about what those parameters look like, and we use statistics in order to do that. A statistic is a sample result. And we take and make an inference from the sample. If we've done our sampling right, we can make an inference from the sample to the larger population. With statistical inference, we start off by having to state the hypothesis in statistical terms. And two hypotheses are specified when we do hypothesis testing: the research hypothesis and the null hypothesis. And it's the null hypothesis is the one that's tested directly. We need two hypotheses to avoid a logical fallacy, what's called affirming the consequent. So the researcher must eliminate false hypotheses rather than affirm the true hypothesis. That's what we're trying to do with hypothesis testing, is we're trying to knock down the null hypothesis. After forming a specific null hypothesis, we test it against a sample result, and that's compared to a statistical model that gives the probability of observing such a result. And the sampling distribution then allows us to estimate the probability of obtaining that same result. And that probability is called the level of significance. With the sampling distribution, you can think of the level of significance is if we want to be, for example, 95% confident that the probability of obtaining the result compared to not obtaining that result, then we would say we have a 95% level of significance, or we have a 0.05 level of significance, 5% level of significance, which would be a very low threshold. A 95% level of significance would be a very high threshold. The chi-square test is a general test that's designed to evaluate whether the difference between observed frequencies, what we get in a table, those are the observed frequencies. The chi-square test is a general test that's designed to evaluate whether the difference between observed frequencies and expected frequencies under a set of theoretical assumptions is statistically significant. The observed frequencies are the actual cell counts in a table. We can, if we need to, if the table comes as percentages, we can convert the percentages over as well. We can use percentages and generate frequencies from those if we have an n for the table. The mathematical formula for a chi-square test might look a little scary. It's the middle item there. What looks like a great big funny shaped E is a sigma sign from math, and it just means take the sum of. So we're going to take the sum of what follows. And what follows is another equation, and that is the observed frequency minus the expected frequency. We're going to square those. And the reason we square those is because they can turn up, if we just took the observed frequency minus the expected frequency, we could get some negative numbers. Generally, what mathematicians do to avoid negative numbers is, yes, they could take the absolute values, but computers are much faster at squaring numbers than they are at taking absolute values. We square the number in order to make everything positive. So we square the difference between what we observe and what we expect for each cell in a table, and we divide that by the expected value, and we take the sum of all of those, and that's the chi-square statistic. And then we look up on a table to see whether or not it's statistically significant. Now, the expected frequency for a table is easy to calculate. It's the row total times the column total divided by the number of observations in the table. So for each cell, we're going to calculate the row total and the column total. We're going to take and multiply those two things. And for that cell, we're then going to divide it by the n of the table. N means just the number of observations. And that will give us the expected value for the frequency. That gives us our expected frequency. To evaluate the chi-square statistic that we obtain with that equation, we need to compare it to the sampling distribution for chi-square, and then observe whether the value is large enough and thus unlikely that the null hypothesis is true. The null hypothesis is that there is no relationship between the variables that we're looking at in the table. That's our null hypothesis. If the difference between the observed and the expected frequencies are so large as to occur only rarely, then we reject that null hypothesis. So if the observed frequencies and expected frequencies are identical, then the chi-square statistic will be equal to 0. So all we have to do is simply go along and look at the difference between the observed and the expected frequencies and see whether or not they're large enough in total that they occur only rarely. And if that happens, we reject that null hypothesis that there's no relationship between the variables. We conclude that there is a relationship between the variables. So chi-square is really not a single sampling distribution. It's a family of sampling distributions. If you go to a statistics book and you look up the chi-square statistic, you'll see that there's a whole table of different values for the chi-square statistic. And to select the correct chi-square distribution to use for our two variables in a table, we do it by level of significance, 0.05, 0.01, 0.001, 0.0001, whatever the level of significance is that we're looking for, and the degrees of freedom. Oh, I haven't mentioned what the degrees of freedom are yet. The degrees of freedom is simply the number of rows minus 1 times the number of columns minus 1. The standard level of significance that we look for statistical significance in most research articles is 0.05. If we want to be really confident that these results are unlikely to occur by chance, we might go to a 0.01%. At 0.005, what we're saying is 5% of the time, we're willing to be wrong in our guess. These values are big enough that they don't occur by chance alone. If we want to be really confident, we go to 0.01. 0.01 is 99% confident, and we're saying there we're only willing to be wrong 1% of the time. If we want to be even more conservative, we can go to 0.001, which would mean one time out of 1,000 we're willing to make a mistake. So we want to be really, really confident. And you'll see results in tables that sometimes even go down to, we don't generally go any smaller than 0.0001. That's generally as small as we go, most research. Anything below that, and you'll see that people will put the less than sign in front of it. They'll say less than 0.0001. This is the last slide. I didn't want to spend a whole great deal of time talking from slides. What I want us to do is actually walk through an example together. I'm going to do an example for everybody, and then together we'll walk through a second example, and we'll do it as a team together. So the calculation steps for the chi-square statistic, when you take them one at a time, when we break out that equation, the calculation steps are pretty easy. We start with observed frequencies. That's just the values that are in the table. We calculate the expected frequencies for each cell. It's easiest to do this in something like Microsoft Excel, and that's what I'm going to use tonight for this demonstration. We calculate the observed minus the expected frequency for each cell. Easy enough to do in a spreadsheet again. Then we calculate the squared value of that difference for each cell. Then we go one step further, and we take that squared value and we divide it by the expected value for each cell. We sum up all of our cells, and we evaluate the chi-square statistic that results. Those are the steps. I've got one spreadsheet where I walk through all of those steps one at a time. And then there's another spreadsheet that we'll work at together where we walk through the same steps. And I don't even know how the results are going to turn out because I didn't look at it. We're going to calculate those results together. Let me go ahead and stop the screen share for a moment. Let's see if there's anything in the group chat. I don't see anything in the group chat.
Yeah, there's nothing in the group chat, but if anybody has any questions on that first part, this would be a good time to raise them, or if you're not clear about anything that he covered. Okay, everybody's good?
Then we'll go to the spreadsheet. What I have here is data from the federal inmate study that I've been looking at. What I did was take a federal study that was done, survey data of federal inmates, and I put that into Sirius. This survey actually has the date and the place of birth for the inmates. So we're actually able to match up the astronomical data with survey questions about federal inmates.
It was a pretty exhaustive survey, wasn't it?
Yeah, it was. Exhaustive is a good word for it. There's I forget how many questions, 1,200 and some odd questions.
Lot of questions, but they didn't have a whole lot else to do, so they answered them.
They answered them. Then I took so I put the federal survey data into Sirius, and then exported out of Sirius the positions of the planets, the speeds of the planets, and then went into a statistical program called SAS and created a whole bunch more analysis variables so that I could create variables that told me, for example, what sign. The variables that we're looking at tonight, where you see the signs along the top, those are the signs that Mars is located in. So we have Mars in Aries, Mars in Taurus, Mars in Gemini, Mars in Cancer, etc. And what we're looking at then...
Do you want to put up the spreadsheet? Or
didn't I put up the spreadsheet?
Not yet.
Oh,
so
I thought I did. There's the spreadsheet. Can you see it now?
Yes, don't worry. We'll forgive you, Mitch.
So you see along the top row, these are the observed frequencies. These are the actual Mars in Aries, Mars in Taurus, Mars in Gemini, Mars in Cancer, etc. These are the actual counts, the actual frequencies. And the variables are whether or not they were convicted of murder or manslaughter.
Murder and manslaughter?
Murder and or manslaughter.
And or manslaughter. So these are the Mars positions of
these are the Mars positions.
Who answered yes to that question? Were you convicted?
It would be somebody who was in prison for murder and or manslaughter, and no would be some other crime. I had to remove anybody whose planets could have moved during the day. So instead of having 6,500 for the number of observations, I instead have 2,985 total observations. If you look at at row number 6, it shows that there's 2,985 under the N column. That is the total number of observations in the spreadsheet. Row 6 is the number of column observation, the number of observations in the column, and column N is the number of observations in a row. So those are our row totals. Remember that the expected frequency takes the row total, 57, multiplies 187 by 57, and then divides by the total N, which is 2,985. And that comes up with 3 when we get done with that. So you can see that in the formula for the spreadsheet, that's all I did was say take the integer value and simply take this value here, B6, which is column total of 187, multiply it by the row total of 57, and then divide that by the total N for the whole spreadsheet, and that's 2,985. And we do this same calculation for every cell. And the expected value of 4 comes up with taking 236, multiplies that by 57, and divides by 2,985. Do that for every cell, and this gives us our expected frequencies. You'll notice that the numbers are a little different. They're not wildly different. They're a little different than they are for the observed frequencies. For example, observe 6 people who were murderers who had Moon in Aries. We expected to find 3.
Is it Mars in Aries or Moon in Aries?
They're all Mars in the sign. This will be true for the next example that we work together too. Taurus we observed 4, we expected to find 4. And likewise, for the no, we observed 181, but we expected to find 183. So the next step in calculating the chi-square is simply to take and subtract the expected from the observed. So we simply take 6 and subtract 3, and that gives us 3. So this is simply the surplus of the observed over the expected. So here in Mars and Aries, we observed 3 more than we expected among those who committed murder or manslaughter. Among those who didn't commit murder or manslaughter, we observed 2 fewer than we expected. Next step is to take the same numbers that we have here, and all I did was square them. 3 becomes 9, 0 squared is 0, minus 3 becomes 9. And then we take the chi-square summation, we prepare for that by, again, simply taking the integer value and dividing B26 right here, 9 by 3. So all we're doing is simply going here, taking this, and dividing it by what's up here. So we take the observed and the expected squared, and we divide that by the expected frequency. When we do all of that, we then just simply sum these numbers up, this whole table. We just sum this whole table up, and it comes up to a chi-square of 12. That's what this whole table sums up to, is the number 12. Well, we have to talk about the degrees of freedom again. The degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So we have 2 rows, which is 2 minus 1 is 1. We have 12 columns. 12 minus 1 is 11. 11 times 1 is 11. That gives us 11 degrees of freedom. And rather than look it up in a book, Excel actually calculates the chi-square distribution statistic for you. It actually calculates the p-value for you. And so in this case, the p-value is 0.363643, and that means that 12 is not different enough from what we would expect, that we therefore were not able to challenge the null hypothesis. Even though it might look like there are some significant differences between those who committed murder and those who didn't by where Mars is located at, in Aries, Taurus, Gemini, Cancer, Leo, etc. In fact, even though we have some that are a 5, some that are one that's a 3 here, another one that's a 3, in fact, by chance alone, we could get a table that looks like this. We therefore did not reject the null hypothesis, and we therefore did not reject the assumption that this is random chance alone.
Okay, so we can't show any connection between their natal Mars in the tropical zodiac and whether or not
they're a murderer.
They're a murderer or manslaughter. There's just nothing there that shows that it's an astrological effect based upon the Mars by sign, by
That's
tropical
correct.
sign. Okay.
I have another spreadsheet that's set up. This one is, instead of it being murder-manslaughter, it's whether or not the prisoner was ever abused. And this could be abused physically or sexually.
Was that specified in the questionnaire, the types of abuse that would qualify?
They are. It's just that the number of observations got smaller. I wanted to have a few more observations on the yes side. Mm-hmm. So I went with any abuse at all. But actually in the survey, you can break it out, yes.
Oh, so you're saying that you went with any abuse at all?
Any abuse at all.
So was there a category for that?
Mm-hmm.
Okay. Would that include verbal abuse, emotional abuse, psychological abuse?
No, it included physical abuse and or sexual abuse.
Okay. Just wanted to clarify.
If you included, emotional abuse, verbal abuse, I'm sure it would run much, 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 much higher, roughly 10% of the population. I mean, if we look over at column N, we have 260 people who said out of 2,883, so almost 10%, suffered abuse as a child, either physically and or sexually. Compared with, if it's under 10%, just under 10%, that means a little over 90% of them did not suffer abuse. Here's where I want it to get interactive, where I want, hopefully the listeners will be able to point me in the direction of the next step to take in calculating the chi-square for this table. I'm hoping that somebody can look back where we're taking notes and can tell me that the next step that we would be taking, how we would calculate the expected frequencies. It'd be fine if somebody could just tell me the formula, and I can enter the formula into the spreadsheet.
Does anybody remember the formula? We got a room full of people. You can either use the text chat, or if anybody wants to turn on their microphone, we can do that as well.
Well, here's a hint. We start out with, for example, column totals, and we're going to go ahead and multiply that. Actually, we want to make sure we get nice rounded off numbers. So I start off with an integer, and we've got the column total, and then we're going to multiply that.
I have a dumb question.
Sure, go ahead.
How did you get that integer? What is that?
That makes it so it rounds off the number, so that when we estimate the frequencies, they're a whole count, just like they were with the other. Oh, how did I get that? That's just a function that's built in Excel. So I say equal int, and then open paren. Start off with the column total or the row total. It doesn't matter. We're going to multiply that by, anybody care to venture a guess?
Okay, the question is, you're going to take...
You're going to multiply the row total by the column total.
That's right.
And the column total is going to be the n number, yeah.
Right, and then we're going to divide by n. We can do this in, like I did, serially, because it doesn't matter with multiplication and division what order we do them in. I could have done the multiplication and put that in parentheses and then divided by n by the total count or whatever. That would be fine too. You got to be careful about the sequence of when you're doing operations, when you start blending together addition, subtraction, and multiplication, division. But since we're doing all multiplication here, it doesn't matter what order we do the multiplying and dividing by. And we get the number 16. Why is it saying minus 16? Int B6 times N4 divided by N6.
I think in your formula you have equals, then you have minus IN.
Thank you.
Oh,
thank you,
no, you're brilliant.
I'm an Excel girl.
There it is. All right. Then what I'm going to do here to make this faster and simpler, in Excel, when you want to use the same value all along in a row or a column, you put a $sign in front of what you don't want to have change. I always, whether I'm looking at the same row or the same column, I always want to use n down here. I'm going to put a $sign in front of the n and the 6. That won't change this calculation at all. It will, as you see, it's remained the same, 16. But now it means if I go up here, I also want to hold N4 the same for everything. All I want to do is change, as I pull along my cells, I want to get a different column total. But I always want them to be multiplying by the same row total. So I'm going to do the same thing there. I'm going to put a $sign.
Hey, we have a comment from Ashkalesh. I think he's in India. And he says he was apologizing that he couldn't answer the question because he wasn't taking notes, but he said it's fascinating. He's trying to absorb the concept. Then Demetra has a question, and I think it's a good one. She says, I don't really understand where you get the data for expected frequencies. Are the observed frequencies what the inmates write down? And I think the short answer there is yes. But
yeah, the observed frequencies are simply counts of yes or no. For the yes row, this is just the number of people for whom I calculated Mars was in Aries for them. They had said to the survey question, yes, I was abused physically and or sexually. This is real, just raw counts of numbers, of like a tally, like almost making a tally of individuals. Okay, inmates, everybody raised their hand who said who's been sexually abused or physically abused, and we count the number of hands, and then we divide that up by the actual Mars sign for those individuals in this, in the tropical zodiac.
And I think that's, the first part of her question is good. I think maybe we need to recap, especially for the more mathematically challenged, and I'm the president of that club. She's saying, I don't really understand where you get the data for the expected frequency. So the expected frequencies
we're calculating it.
Yeah, we're trying to figure out.
We're calculating it
the
from
average number that we would expect. to occur under each sign. And we're going to do that mathematically by taking the
column total.
The column
Multiplying
total would, okay, now when you say the column total, you mean the total for each sign.
I'm taking 178 for this cell here, number 12.
Right.
I'm taking this column total here, 178, is the total of 13 and 165.
Yeah, but what it is, and this is, I think, the difference between people who do a lot of math and the mathematically challenged. The mathematically challenged need to know what it is, not just the numbers. But this is the number of people that have Mars and Aries. That's what the column total is. You've got a separate column total for Mars and Taurus, for Mars and Gemini, for Mars and Cancer. That's what the column total is. So you're going to take the column totals, and then you're going to
get the row totals. We're going to multiply it by the row totals. So the row is just
row is yes or no.
Yes or no, ever abused. And then we're going to divide by the total number of observations in the table, 2883.
Column number times the row number, then you're going to divide by the total number of observations.
Right.
And that gives us the expected frequency, because then it's going to spread them out over the 12 signs again.
That's right.
Okay. In plain English, for the mathematically challenged, that helps a lot.
Okay.
I hope that answers your question, Dimitra.
Feel free to say so, Dimitra. And then we have to do the same thing.
Yeah, it's easier to unmute than to try and type it out.
Sure.
Okay. Yes, it sort of answers my question. Is there an assumption here anywhere that all the signs should or would have an equal number?
That's a really good question, because they don't.
They don't, and there is no assumption, and there is no assumption that they would have the same number. Okay. No.
Well, they've all got different totals too.
Right.
And those totals are at least somewhat reflective of the astronomical distribution, somewhat.
Right. In fact, I have data that I'll be presenting at the Kepler conference where I actually strip out the astronomical factors. You can see that there's almost 2-to-1 difference between, for example, Cancer, where we have 33 individuals who said they were sexually abused, over 322 who had Mars in Cancer for all of our prisoners. There were 322 of them. 33 of them had been abused, compared with, we go down to a low of 13 in Aries. We've got more than a 2-to-1 spread in our data as we look across the different months.
Right. It seems just on a quick look that people who have Mars in a water sign seem in general to have higher yeses.
Mars in Cancer, Mars in Scorpio,
Mars in Pisces.
And we could break it out that way. I didn't break it out that way, but it's certainly possible to take a look at to break it out by element. That's certainly possible to do to me.
Yeah, so why don't you continue, and then that maybe then afterwards that's something you could go back and see if it isn't so much by particular sign, but if elements play a role.
Yeah, well, it is an interesting observation that, Mars is presumably traditionally debilitated in Cancer, and, that's the sign that really scores the highest for yes to abuse from, and you can see along the bottom in the totals there, it's sort of representative of the astronomical curve. You're always going to have more Mars and Leo and Virgo in the tropical zodiac. There's going to be something of a curve there, and it's pretty reflective of that. Not exactly, but close.
I'm just getting set up to do exactly the same thing with the next row that we did on the row above. I'm just making certain that the spreadsheet stays focusing on what we want it to focus on. So now I can drag it across. And so now we have our expected frequencies. We expected 161 had Mars in Aries. We expected 16 of them to have been abused. And in fact, when we look at it, only 13 of them have been abused. Some other ones, we wound up having 32 people in Scorpio having been abused out of 264 individuals, I might add. So it's it's about 15%. We only expected 23. We have a bumper crop
of Mars and Scorpio, the most passionate sign of its rulership. That's really interesting.
But the question still comes down to, is this still different enough that we can conclude that there is a difference, or are these differences still going to be so slight that we can't conclude that there's a difference? So now we take the observed minus the expected, and that's straightforward. We take the observed, 13, and we subtract the expected. And I'm just simply going to drag across the formulas. Now we square what we just did here. So we take these rows, and all I'm going to do is simply square them. This will equal this times this. Just multiply it by itself. Before I go to the final step, I'm going to have to change 0, and you'll see the reason why, and that is because I can't divide by 0 in the spreadsheet. So when I get down here, I'm going to actually have to change things. We're going to now take these values that we have here, and we're going to complete our chi-square summation. We're going to go in here and take this value equals this value divided by chi-square summation equals the integer value of this divided by,
Okay, and specifically, what are we doing in this step? Just for my benefit, you're getting your chi-square summation, but you've got the observed and expected values squared. So
in this step here, this is sort of the final step in the process. If I go back to, and in this final step, as I show here in the formula, it simply takes this number here, 9, and divides it by this number here, the observed minus the expected.
okay, so you're taking the observed, expected squared, you're dividing it by the observed
minus the expected.
Minus the expected. Okay.
Which means that my formula.
This is the manslaughter one.
Yes, I know.
Okay.
And so I now have to sum up the table, but before I do, I have to change where it was dividing by 0, because I had 0 in my denominator up here. I have to now change these manually to be zeros real quick, because otherwise it won't sum properly.
Right, okay.
And we're back to having a chi-square statistic. This number here for chi-square is simply the sum of that. And miraculously, it turned out to be the same number that we had for murder-manslaughter, 12. We still remain with a p-value of 0.3636. It means that we cannot rule out a table like this from random chance alone. There is no relationship between the tropical sign of the planet Mars for a given inmate and their natal Mars, and whether or not they had been abused sexually or physically.
Okay, so there's no statistical significance to this distribution. There may be some practical significance in there, but not statistical.
That's true. There is no statistical significance between those two variables. Dimitra raised an interesting question, and that is looking at it by element, and we can look at it by element. We could look at it by fire, earth, air, water. We'll go with the traditional 4. This equals this plus Leo plus Sagittarius. And then for Earth, Virgo plus Capricorn. And then we've got air, Gemini, plus we've got Libra, plus we've got Aquarius. And for water, we've got Cancer, plus Scorpio, plus Pisces, 90.
Yeah, look at that. That's a big difference, but we'll see if it's significant.
Now we go ahead and I'm going to do the same thing. I'm going to say this is the sum of this row here, and this equals this plus this. Get my column totals, and get my total n. So I'm back to 2883, so I haven't lost any individuals. So now we're going to do the same thing, same sorts of calculations that we made a few minutes ago. I'm just going to go ahead and fill out the.
Well, there's more water Marses in this group overall, which is kind of interesting too. There's 799 natal Mars and water of the prison population. It's just an interesting little take. The second highest is the Earth. But then
Yes.
Quite a bit less of
Second highest is fire at 61.
But the Earth is 741.
Oh, you're talking about total
Yeah.
Earth.
Yeah.
Okay. Yeah.
Yeah.
I was looking at
Yeah.
looking at just Earth. Yes, I'm sorry.
Yeah, the water's high and the fire is low. That's very interesting.
Mm-hmm.
Considering it's a prison population.
So now we calculate the observed frequencies. Anybody want to remind me how we do this?
Oh, wait a minute. It's in the chat. Didn't you have to take your row totals and your column totals and multiply them and then divide them by the total number of observations?
That's how we do it.
I can't believe I remembered that.
This equals this times this divided by this. And I wanted to make that an integer. So I'll slip that in there. 59. And so I can drag and drop all the way across. I'm going to make this U6, the $U.
Akhilesh, and I hope I'm saying his name correctly, he says you can copy cell Q4 to U6 and paste it for all others. It will automatically pick the formula.
This one here, again, we multiply the column total by the row total. So that's our expected frequencies for the different elements. So 1/10, 1/10, 1/10 roughly, 1/10 roughly. So I don't have much hope that even when we do it by element that we're going to find a statistically significant difference, but we'll work it out. We'll go and see. So the next step is observed minus expected. It's observed minus the expected. Come on across. And then we have the observed minus the expected squared. This equals this times this happy guy by himself. And now, for the chi-square summation, anybody remember how we did the chi-square summation?
Anybody remember? Wasn't it?
Before I flash it on the screen?
You take the observed and the expected and squared, and you divide it by the expected. Maybe.
Mm-hmm.
Really?
Mm-hmm. That's why I was trying to show back on the formula. The formula has the sum of that difference and then the expected. That's right. We're going to divide it by the expected. That's right. So we have the observed squared. This equals this divided by the well, our chi-square is going to be the sum of all of these. Chi-square is going to be the sum of all of those. It's going to equal the sum of all of these. And it's a chi-square 4. We have 3 degrees of freedom because we have the number of rows minus 1 times the number of columns minus 1. And then we calculate the chi-square statistic. That equals chi-square distar t. For that, we have to enter in, I believe it's the degrees of freedom first. That's a right tail test, 4, 3. And our chi-square statistic is 0.261464. Still not statistically significant. There's no difference between the two variables, even when we break it out by element.
And Teresa's making a comment, the tropical water signs fall in the area of the Gemini triplicity signs. That would be if you're comparing tropical to sidereal. In Jyotish, Mars has a reputation of being badly placed in the Gemini trigon, Gemini, Libra, and Aquarius, maybe because there's no Mars sign rulership or exaltation in that trigon. Saturn is a triplicity lord for the Gemini trigon, can be a tearful trigon, so in the same area of the ecliptic as the tropical watery signs, which brings up the question, I wonder if we get any difference in the numbers if we were working in like Lahiri Ayanamsha, a sidereal zodiac, rather than the tropical. I don't know if there's any way to switch them easily, but it is an interesting point. You know, obviously there's more water Marses, but there's more abuse with the water Marses, but there's just more Mars and water signs overall. So that kind of balances out at the end of the day. But it would kind of be interesting to compare the sidereal placements versus the tropical placements. And she's saying, yeah, you'd have to compare each tropical sign with the preceding tropical sign. Yes, interesting to compare. And again, you know, I think one of the problems historically in astrological research is people having to do a univariate analysis. Like here, we're just looking at one variable, the Mars in the signs, and it's hard to get a significant result that way, you know, when you just pull one thing out of the pile. But that's how you do it. And it's not like people haven't gotten significant results using the chi-square test. They have. You've just got to be, you know, testing the right thing. But in this case, there may, as you always like to point out, Mitch, there may be some practical significance to the Mars placement with these prison inmates, but trying to demonstrate that statistically using a chi-square, you know, it's just not strong enough to really measure. And Robert's asking, he says, the question in my mind is, while Mars in Cancer seems higher, but the chi doesn't support it, as the null is supported, then what about additional factors, say Mars in Cancer and Moon in a water sign, etc.? Yeah, once you start getting into a multivariate analysis.
Right.
And you know, that's how astrology actually works in practice. That's how astrologers actually operate. You know, they very rarely make a judgment off of a single factor. You know, usually there's several factors playing into it. But again, I mean, there are tests that get positive results using the chi-square.
Oh yes, there are results. There are in the literature. There are positive results with the chi-square statistic. It's just that in this case, these two hypotheses, they weren't supported by the data.
I think that is one of the most challenging and creative parts of research design, is coming up with the right question to ask.
Even when we don't confirm a hypothesis, we learned something. We learned that there's not supporting evidence for the natal placement of the moon in tropical signs. Mars, excuse me, in tropical signs, leading us to conclude that there's a statistical difference between those placements and either whether or not somebody's a murderer, committed manslaughter, and or whether they were ever abused physically or sexually.
Mm-hmm.
So we learned something either way, even though our hypothesis that there was a significant difference between them didn't pan out, we still learned something, which is that's not the case.
Well, you know, now that I'm thinking about it and I'm digesting it, it's interesting that we came up with more Mars in water signs for that whole group, because Mars has a pretty well established astronomical pattern, and in the tropical zodiac it's going to be higher in Leo and Virgo.
But it's not higher because it's as a proportion. If you look at it, you got 90 individuals in water signs out of a total of 791 water signs. So that's 10% roughly. We had 53 out of 689. We had 56 out of 741. And we had 61 out of 662 individuals.
Wait, okay,
So,
I want to make sure I understand those numbers. Okay, I'm looking at the 791.
we have more
Water
individuals,
signs.
yes,
Yes.
but as a proportion, the proportion that were abused, the proportions are roughly the same. They're pretty much the same. That's why we're not getting it.
Well, that's not the question I'm asking.
Okay.
The question I'm saying is that of these four elements, the Mars is highest in the water signs, 791.
Mm-hmm.
Then 741 for the Earth.
Mm-hmm.
600, okay, and the fire is the lowest. But according to the astronomical distribution, that might be significant, maybe, because Mars has such a specific astronomical distribution. It's going to be higher in Leo and Virgo, not Pisces, not Scorpio, and not even necessarily Cancer. So maybe there's something in that, for instance, if we were to get an astronomical distribution of Mars through the elements for this time period verse. Yes.
Can I add something to this discussion?
Mm-hmm.
Please.
Curious to see what is the range of years of the participants in the study. Were they all born like within a 20 or 30-year span of one another?
No, their ages vary. They varied from.
Yeah, but how many years is the span? And the reason I'm asking is that Mars has an anomaly in its cycle where it doesn't spend 2 months in each sign uniformly.
Right.
When it's making the square to the sun, it can spend up to 9 months in 1 or 2 signs because it's slowing down at that point. So in looking at these numbers, I would be curious to look at the years when these people were born and to what extent that anomaly in Mars orbit was a factor in giving more counts of Mars in certain signs than in other signs.
That's exactly what I was saying, Demetria. Mars has a definite curve in its astronomical distribution. It's not flat at all. It's a definite curve, and it's always higher in Leo and Virgo, and there's a curve.
Yeah, well, that's sort of based on the ascensional times of the signs. But what I'm talking about is a different factor of its synodic cycle relative to the sun.
Mm-hmm.
Yeah, it's based on the retrograde period. We do a lot of astronomical frequencies. I calculate astronomical frequencies for data samples all the time. So I've got a pretty good working idea of what the Mars distribution is.
Throw these numbers off from what is seemingly obvious.
That's what I was saying, is like, I don't think that you should necessarily have more Mars in water signs in a flat astronomical year. That's intriguing.
Unless Mars happened to be in Cancer for 9 months during a set of years when a lot of these samples came from.
Right. We'd have to actually set the frequencies for the range of birthdays, which is what we do on a very regular basis. Like I'm the one who goes into Jigsaw and does that because that's one of the things I actually know how to do. So I end up doing it. I leave the real heavy lifting to guys like Mitch, but I can do the astronomical frequencies. And it caught my eye right away because I don't think it should be higher in water signs necessarily. You'd actually want to look at it, but that might be something worth testing. Now, Teresa's bringing up an interesting point. She's saying if something isn't statistically significant, it's not really truly practical, is it? I so often wonder about statistics and astrology. I think, as Mitch has pointed out, there is a difference, and they're both important. There's statistical significance and there's practical significance. I mean, and Mitch, stop me at any point and correct me here, okay? But just because maybe you can't prove that something is significant astrologically to the point of statistical significance, that doesn't necessarily mean that it's not knowledge that would be a practical use to, say, a working astrologer. And Mitch, maybe you can put that better than I just did.
Yeah, well, I flip it around, Courtney.
Okay.
Sometimes what happens is we get statistical results that are statistically significant, but when we're testing for statistical significance, generally what we're testing is whether or not some effect is different from zero, okay? And the statistical significance tells us we can be confident that the result is not zero. Well, the result might be so close to zero that you wouldn't care. In other words, something can be statistically significant, but not practically significant at the same time. The fact that something is statistically significant doesn't mean that it's a big enough impact, a big enough effect that we should care. You have to demonstrate both that it's statistically significant and that it's substantively significant. That the difference between them is so big that somebody would care.
Well, and let me try to put it another way, and again, correct me if I'm wrong. For instance, on the Nakshatra project that we're doing, there's a lot of nakshatras. There's like 27 of them. And we've been testing them on the Gokulan professional categories. So let's say we have a professional category like, actually the one that comes to mind, I believe, is the artists, the painters. That it's thousands of painters. And in that case, when we looked at the sun in the nakshatras for the Gokulan painters, the sun in the nakshatra Hasta was really high compared to its distribution throughout the rest of the nakshatras. And while it wasn't exactly to the level of statistical significance, and again, with so many nakshatras, that's tough getting anything to statistical significance. But from a practical point of view, I think in presenting, say, that work to astrologers, it would possibly be fair to say, based upon the Gokulan data, that the sun in the nakshatra of Hasta could be an indicator of someone, all other things being equal, who might choose a career as a painter. That's a practical significance based upon the evidence. And we're seeing a lot of things like that in the nakshatra study. Just different preponderances and propensities that aren't necessarily statistically significant, but from a practical point of view. And how do we use the nakshatras, particularly in determining professions? There's some practical uses for the information that's coming out of that data. Robert has another point here. He says, I just want to point out that the range of Mars in element is 23% for Aries and just over 27.5% for Cancer. And over 4 elements, the average is 25% grossly. Again, we'd have to compare it with the astronomical frequencies. So it seems there really wouldn't be enough of a difference to even be practical, let alone statistical. Sorry, elements, fire and water. Okay, so he meant the range of Mars in element is 23% for Aries and just under 27.5% for Cancer. Okay, so he's saying it's not enough of a range to be even practical or statistically significant. Right. And that's true in this particular data set. It's a very simple question that we asked to the data. Having said that, Robert, I want to point out that there's actually quite a body of evidence for the tropical elements. That's one of the strongest bodies of evidence in the research right now. But again, it depends on the question.
I just fixed an error in the spreadsheet calculation, Courtney. Mm-hmm. When we look at it by element, it does come to statistical significance at the 0.07 level.
What?
It does come to statistical significance at the 0.07 level. What was the mistake that I made in the spreadsheet? Remember the chi-square summation step here?
Uh-huh.
We don't divide that by the observed expected squared. We divide that by the expected frequency. Expected frequency is in the bottom of our equation.
So actually, the water is a little bit significant?
Yeah, if you accept 0.1 as your level of statistical significance, then it is statistically significant at the 0.1 level.
Well, 0.1, okay. Well, that's very interesting.
90%. We could be 90%. We could be 90% confident.
That's really interesting. And you know what? I have a feeling that if we were to then take another step and factor in the actual astronomical distributions, it might actually bolster that, maybe. Mm-hmm. So actually, we got a result, sort of.
Yeah.
At a 90% level.
Yeah, I screw up the formula because it's the observed minus the expected squared, and we divide that by the expected frequency.
Aha, so Robert, there may be some statistical significance. And bearing in mind, I'm saying this because we're just going to press right now with an issue of correlation where we have a number of articles that all show statistical support for the elements of the tropical zodiac, as well as a literature review with a whole lot more papers that do the same from a lot of different kinds of studies on different population samples. And one of the reasons I'm bringing this up is I quote from Peter Roberts, who's quoting Bayes' theorem in there, that every time you add another study to the pile of evidence, it kind of lowers the burden of proof. So at this point, if we're looking at the elements of the tropical zodiac, the burden of proof is getting a lot lower. And that also raises the practical significance of what we're learning about the elements. So you don't want to just look at this in isolation. And that's amazing right there, that it's 2018. And there's actually enough evidence for the elements in the tropical zodiac that we don't want to just look at this as a one-off experiment. It's actually part of a body. Let that soak in for a minute. That's actually really important. It makes me very happy. So we may have something there that
So
we can,
Demetra was onto something when she suggested breaking it out by element.
yeah, I'm assuming she was eyeballing it and saying, yeah, they
That's
look
exactly what was happening. I was just looking at the numbers, and I, startled when I saw Mars in Cancer, and then
and
just
Scorpio.
scanned. Yeah.
And I went to the same thing. I was kind of going through the same process because now I'm really keen to looking at the elements because
Yeah.
it's a good experimental question to ask. We're
Yeah.
really getting results. And so I would say that, look, when we're considering further questions to ask of this prisoner data, maybe we want to ask some more questions of the data along those lines. Even something as simple as one planet, Mars, in the 12 tropical signs. And Lord knows what we would find if we actually switched it to like the Lahiri Ionanshar, the Fagan-Bradley sidereal zodiac.
Okay, so that's been wonderful. I have to leave now, but I'm just so excited to be back in these discussions. So thank you, Glenn, for a wonderful presentation and Courtney for orchestrating all of this.
Yeah, we're really glad to have you back, Demetra, and we're looking forward to seeing you in January. She'll be here for the Kepler conference. She's got a great baby.
Wonderful.
Yeah.
Okay,
Be my chance to meet her.
Yeah.
Thanks, Demetra. All right. Any other questions or comments now that we've found another another little bit of evidence for the elements? Everybody got a handle on comprehending what we were doing.
It should help make the chi-square seem less mysterious anyway.
Yes, less mystery. And Maureen saying that was great. It made it so much easier to understand, so much less mysterious. Myself, I don't know if I'll ever be the person who actually goes in and calculates it myself, but I think it's so powerful and so valuable just to get a growing understanding of what you're actually doing in that process.
Well, when you have a table like that, when you have a table that you're presenting results from where you have two variables and you want to know whether or not they're related, then you apply the chi-square test to the table to see.
Good. Well, if everybody's good, we're right at that 90-minute point. So thank you so much.
Time for everybody to go watch the election results.
Yes, just don't let
I appreciate you giving us time tonight away from the election results.
Yes. Well, thank you so much, Mitch. That was really enlightening, and I think you gave everybody quite a bit to take home and to think about. And we also got, I think, some better some good ideas for, as I said, directions for further research in that
Right.
data sample, in that prison data.
Right.
Yeah, it's very interesting. We learned a little something about Mars and the water signs.
Learn a little bit about Mars and the water signs.
Yes. Well, thank you so much. Well, good night, everybody, and thank you so much. We've got another class in 2 weeks.
2 weeks.
On the third Tuesday, we have a Mercury Research Hour at the end of the month, and then we're doing the first Tuesday in December as well before we take our holiday. And
The plan for 2 weeks, for those who want to know before they all leave, the plan for for our next meeting is to actually take earthquake data and load it into Sirius, and then explore it together. See what we can find learn about earthquakes and astronomical phenomena in Sirius.
Yeah, that'll be good. That'll be very hands-on, and who knows what will turn up.
Pardon?
All right, who knows what will turn up in that?
Who knows what will turn up?
We'll find out. Well, good. And it looks like Robert is saying something.
Oh, I was just going to say good night and thank you. It was all
Thank you.
interesting.
Thank
It
you
was,
very much for coming.
yeah. Is there a workbook for this?
No, but I can certainly share the spreadsheets.
Oh, that would be great. Yeah, and
Spreadsheet
yeah,
in the PowerPoint.
yeah,
We
that
could
would
put
be
them on the page with the recording.
Yeah.
That would be a good idea.
Yeah.
Good. Well,
Thank you.
and we hope that we see all of you at the Kepler conference. Don't forget that's coming up in January.